Alrighty, welcome back to our final few lessons in our Unit 2. We're just about wrapping up our first unit, which is very exciting. And today we're building on our conversation of linear inequalities. Last lesson you talked about how to create inequalities. Today we're going to talk about how to graph inequalities, and on the next lesson, lesson 23, you're going to learn how to solve inequalities, right? This is what we're doing for the next couple days. And so the objective for today is I can use graphs to represent the solutions of inequalities with two variables. So today we're talking about what it looks like graphically. And so our first activity is to observe what solutions look like. And so I want you to take a second. What are two things you notice about the plotted points? And what do you see? Remember, don't just give me that there are blue dots and yellow X's, right? I want more in depth. What do you see here? What do you observe? What would happen if I extended up and to the right, or and extended down and to the left, right? Would they be blue points or would they be yellow X's? And now we get on to what it means to sketch solutions of inequalities. So initially I give you a graph of x minus y equals 5, right? Which should be familiar from our previous lessons before our midterm. Now we are sketching solutions to those inequalities. And so when we're sketching our solutions, we test points and see what happens, right? And so if I have, this is my line, right? This is x minus y equals 5. And so the question is, do we have points that are greater than 5 or less than 5? And that's where we want to test our points. And testing points comes from choosing one coordinate pair. In this case, I'll choose 0, 0, and see if that makes my equation true. So if I substitute in 0, 0 into my equation, I get 0 minus 0 is less than 5, which gives me 0 is less than 5, which is correct. So I know that that is a solution. On the other hand, if I choose a solution on the other side of my line, a point, let me choose 5, negative 5. If I substitute that into my equation, I'm going to get 5 minus a negative 5 less than 5. 5 minus 5 is, I have to write this way, is 5. I don't know why that's happening. 5 plus 5. Right, let me erase this just for now. Right, I have 5 plus 5 being less than 5, which gives me 10 less than 5, which is an untrue statement. And so I know that any point over on the right side of my equation is not going to be true, because when we talk about solutions to inequalities, it is a set of solutions. We talked about this yesterday. There's multiple numbers. Like we know that 2 is less than 5. I know that 1 is less than 5. I have multiple solutions in my inequalities. And you can test other solutions too, right? If I did the solution, if I have the number 1, negative 1, right? Substitute that into my equation. 1 minus negative 1 is 2. 2 is less than 5. That's also correct. And if you keep trying them out, you'll notice that this entire part of your graph are all solutions to your equation. And that's the goal of today, right? We want to learn and realize that we have multiple solutions to your equation. And what does that represent? And so we're showing that all those coordinate pairs are solutions to my equation. If I choose any of them, right? If I choose 0, 9, right, in this case, or if I choose negative 5, 0, right? All of these are solutions, and you can keep testing that and seeing what's happening. And so you want to do the same thing for the next two slides, right? The next slide, and talking about solutions when x minus y is less than 5, or when x minus y is greater than or equal to. Remember, when you have a strictly less than, it is a dotted line. And if you have a less than or greater than or equal to, you have a solid line, because those also represent solutions to your equation. In 21.3, you are now matching your equations, right? Some of these are a little more straightforward, right? X is greater than 3. So now we want any x value that is greater than 3. Now, what does that look like? And just a quick reminder, this represents your x-axis, your horizontal axis, and this represents your y-axis. And then in 22.3, right, we get into understanding what it means in context and finding the graph, right? A vendor in the Saturday market makes $9 profit on each necklace she sells and $5 profit on each bracelet, right? So if I represent, if I'm creating exactly two profits, right, I want let's say I have X, my X value is my number of necklaces, necklaces, and Y is my number of bracelets. How can I create my equation? Bracelets. Right, my equation when there's exactly $100 profit. Remember, this should be a review from before. And then what does that inequality look like when I'm more than $100 profit? And so once you find out those points, right, here you're just finding a combination. I just want a number, right? You don't have to create your equation at this point, right? I started to create my variables, but I just want to, how many bracelets and how many necklaces, right? You can be like, okay, 10 necklaces and 10 bracelets would be more than $100, right? Oh, that's all you have to write up for this part. And on the next slide, you're creating your equation and your inequality. Last but not least, then I want you to graph your inequality and explain, and I want you to observe what the solution looks like, right? If I'm creating my inequality, and if you're struggling to write your inequality, click the bottom, and you have a greater than, a less than, and your greater than or equal to signs here. So, right, you just plug in your variable, and then you just be like x is less than 3, and you get all of your solutions there. And so you want to see where 3 and 18.6 and whether that is a solution or not a solution to your equation, and describe why or why not. And last but not least, you have your lesson summaries that have describe everything that I was talking about and a little bit extra as well. So I will see you in our final lesson, lesson 23.